Hello guys, welcome back to my YouTube channel Alpha Stack. So today we will be going to see how we can minimize our DFA. So here you can see that this is our DFA which is having one final state only, and here first of all, for minimizing the DFA we have to follow some steps which are here. First we have to check and remove the dead state. If in this DFA is there any dead state, then we have to remove, and also the transitions will also be removed from there. Further moving, as in this case there is no any dead states present, so we will be moving to the furthermore step. So here in the second step we can see that we have to remove the unreachable node. Means basically from this starting node A we cannot reach to that node in any of the circumstances. So here from this diagram you can see that the node D, we cannot reach the node D in any of the circumstances when we will be starting from the node A. So we will be removing the node D, and it's all the transitions also, basically these D to C and D to G, this will be removed. Now further moving, we will be following the steps in this way, like we will be splitting the states in the two ways, which is non final state and final state. Non final states consists of these. Here we have not included the D, as D has been removed, and in final it's only one state, so we have put here C. So now here I have put 0 and 1 because the upper arrow shows the direction of the 0 state. The upper arrow shows the movement of 0 from A to other state or etc., and the below shows the transition of 1. So now moving further, let's see. So here you can see that in this from seeing this diagram, if we see that for A is going to be for 0. So as A and B belong to same set, so we can say that A belong to this same set for 0. Similarly, we will be doing for all these things. While doing for F, it will go to C. As you can see that for F it is going to C. So this is referring to the other set. So we can say that this should not be present in this set. So now we will keep it in another, we will make another set in which we will keep it. Like you can see that here in further next step I have placed it here. And also note that there is no any need to check for the transition of 1 then. For that particular thing, if we have checked for 0 and it's on the other state in comparison with the other states in that particular set. So now here we have not checked for F for the transition of 1. So now as you can see that other have successfully fulfilled the condition for being in the same set as 0. It's not basically the condition that they belong to same set, they can belong to any set, but the thing is that they should be similar to all the states of a single set should be similarly directing or pointing to the other state. So now let's check for the transition of 1. For A it belongs to the same set, for B it belongs to C, and for H also it belongs to C for the transition of 1. So here we can say that B and H are also showing the different behavior by directing to the different sets. So from this we can say that F, B and H, we are making a different set of these, and A, E and G we are keeping in the same set, and C is separate. And also note this thing that if the set size is a single state, so no need to check it, as basically no need to check because its size is only 1. So now moving further, let's move to our second step. Here second steps, you can see that A is A. So now we will be again be checking because we have split it into the different sets. So we need to check it again. So now for checking, you can see that for A, E and for A and E, it is moving to the set FBJ. It is referring or pointing to the set FBJ. It is pointing to any of this state, but it is pointing to this set. It matters. And also note this thing that it is not necessary that all the values will be pointing to the same set. Like it is not necessary that if AEG, let us suppose if AEG points to this set, so it doesn't mean for the transition 0, so it doesn't mean that AEJ will point to the same set only FBH, sorry, for the transition 1. It is not necessary. Note this thing. Now here you can see that in this particular case G is belonging to the same set, so we can say that G is different from A and E. So we can separate G. You can see here we have separated G from AE in the next step. And also we have not checked for 1 as there is no any need because it is not satisfying for 0, so no need to check further. So now as we have splitted it further, so you can see that now AE, FBH, CG. So now we can see that AE to FBH. So now we will be again checking that for A, for B, for A, for E, it's going to the same set. So it's satisfying for the transition A, transition 0, sorry. So now we will be checking for A and E for the transition 1. So here also A and E going to the set FBH. It can also go to the another set also. That will be also fine. The thing matrix is that the for a particular transitions, like for transition 1, it should point the whole set point to a different set, but should point to a single set. It can be different than FBH, like it can point to the C. No, nothing to worry about that, but it should all the elements of the set should point to the that single set or belong to that states in that present set. Now you can see that here we have checked that for A and E it's fulfilling. Now further checking for the FBH. Here you can see that while checking for FBH, you can see that for F it's going to C, and for B and H it's going to G for the transition of 0. So here we can see that F is different, behaving differently, so we can separate out or split out F separately, and B and H remains. So now moving further to the next step, here you can see that after splitting and checking now, so you can see that AE, now we will be again checking all the things for 0 transition for AE. For both A and E, if we separately check, it belongs to B comma H. Then checking for A and E for transition 1, it will be belonging to F, the thing which I am saying earlier. So you can see here also. Now moving for B or H. Now for B and H, they both are belonging to the set G. And now here you can see that we will checking for the transition 1 for B and H, it is belonging to C, which is also belonging to this same set. So you can say that from here we can say that all the states are existing perfectly. So hence the minimum number of states required to represent this DFA is 1, 2, 3, 4, 5 states. And here also note that no need to check the single state. Here this is the DFA which will be minimized DFA created. This DFA is minimized to this DFA. Now in order to create this DFA, just write these all the states here, and then using this diagram, like you can see that for AE you can choose A and you can see that A for A, it's going to B for transition 0. So you can say that here is it's A, it will be going to the B for transition 0. As both B and H state behave same, so and similarly A and E states behave states same, so we have placed it in the single state. So you now similarly you can make this DFA. And also note that if in the set there is even a single state which is the final state in the main DFA which is given in the question, to minimize that, so that whole set will be the whole state, the combined state will also be the final state. Here as we only see, so here C is the final state only, but let us suppose the B is let us suppose that P is also the final state here in this question, let us suppose, then here B, this state will also be would also be the final state only. So that's it, that's for the DFA minimization. Hope you like my video. Do like, subscribe my channel. Thank you for watching.